today we are going to talk about bringing ideas to life. Idea is very, very important to every walks of life, and we are in a uncertain circumstances today, and it is more important that we take care of how to bring ideas. The COVID has come, I know, and from nowhere, people say Wuhan, but it is here to stay, and we have to learn to live with it. And what exactly it has done for us? All the plan industries had, you know, students had, and the whole country and the world, the plans have got demolished, because of this pandemic. And today we are trying to build a new world order with all the digital tools what we have at our disposal. And idea is very important here, and those ideas have to be brought to life, including a vaccine for COVID, which is being passionately pursued at various institutes, including IISc. You know, and ideas are very fragile. If not parked, they will fly off. It's very, very important. And ideas are highly contagious also. So when you externalize an idea, you know, it is very important to park it. So externalizing, so whatever you have a thought, you externalize it, putting on a paper as a sketch, a doodle, right? And more people will look at into it and they contribute to it, and that's how it is improved. And then after you make the improvement, it has to be tested to make it better. Ideas, there is nothing like a best idea. Ideas can be better. Keep on. It is a continuous process, just like excellence. How excellence is a continuous journey towards making yourself better. Idea is also like that. Idea can only be better. There is no best idea ever. You know. And how ideas have been done in industry, we externalize the idea as a sketch, and then lot of prototypes are made, and we are going to see some of them meet the needs of desirability, feasibility, and viability. These are three things which will drive how ideas reach the end use. Then you are said to have done the innovation, taking it to people. you know and this idea creation has been done in a very systematic way in the world. It is called new product design framework. Okay. And sometimes in recent times, people call it as design thinking. Okay. We learned it as a design methodology. Okay. And so a need is going to drive everything. So need for businesses is to make profit, so they look at the opportunity. Need for designer is user, so it's called user centric design. And so ideas are going to be, many ideas will be created, and you're going to screen with a set of criteria, and you go into the detailing of it. That is the embodiment design, nuts and bolts of design. Then this idea has to be tested. So one may wonder why ideas need to be tested. Idea, I've all thought about it, it should work, right? So there is a business case why people have to actually test an idea. Because when you ideate and conceptualize, you're not investing too much of investment into it. It is like in a canteen or coffee board, tea board, you can sit and on a paper napkin you can start drawing something. So idea is born. you know and when you do detailing, and when you want to make, somebody has to finance it. The cost committed curve you can see in orange, and cost incurred curve, which is in blue, they are opposites. So you can see. And that's why enterprises all over the world, they want to test the fitness of an idea, how good or how bad it is, before actually funding it. And that makes us, the idea has to be tested, before it can uh, go forward. And why people do ideas can be tested at various stages in the NPD. Concept development, you can see there are two stars. System level design, so you can also think of a schematic. I have a a rear driven engine or a front driven engine, or have a 3-wheel or 4-wheel or 6-wheeler, that kind of decision, system level uh, decisions. So then we go for detailed design, the nuts and bolts of design, thickness, material, strength, etc. Then you have 3 stars for testing and refinement. Why there are 3 stars in testing and refinement? That's because this is where people are very important, to retain your competitive advantage. You should not fail in the marketplace. You should fail in your idea kitchen, your R&D, your design and development stage. So Lagatar designs are getting refined and tested till you make a somewhat good one. Then of course, production ramp up also people use prototypes, and how we have been doing it before. People used to make ideas using clay, a puff material, or a cardboard, or in electronics we use breadboard. As a ham radio operator, I used to manage for some time the club station at IISc. It was called VU to IIS. So we used to have a lot of electronic stuff, circuits, rig up and check whether it works. It never used to work in the first place. That's a new trigger to learn about why it is not working. So in the design iterations, lot of these things will keep happening, and it is a continuous cycle. You do a check and do check, and then you go ahead, and it can be so today with the advent of computers and all of these have become virtual. you know like you can do all kinds of animation, simulation, giving actual color and finish, those things. And you can also have a virtual testing by simulating on a software, whether the component is fit for its intended use or not. You can even check the kinematics, by having a small animation run, again a simulation, all this. But when you go to the industry, the boss, the people who finance or venture capitalists, you tell them, okay, I've done a design, it works fine on my computer. They'll not be, uh, they'll not be convinced. You need to make them convinced by actually offering something which actually acts and works and demonstrates the capability. So the touch and feel of real model is very, very important. And this is where, many designs used to fail here. There are several valleys of death. One of them is idea which was not able to demonstrate to the quality level what you intended to, you know, and that was a greatest disadvantage. And if you want to make a clay model and things like that, you need to have a lot of skill, you know. So the whole world is looking at the prototype landscape. If you see, it is born as a doodle, and you may go and do a detailing on an engineering drawing sheet or AutoCAD. Then you can even have a 3D virtual model today. You can 3D print it. And if you want to make a virtual working model, for example, you actually need to go to a lathe or a milling machine and make it. So the final product, will cost you a lot. A doodle doesn't, but the fidelity, a doodle cannot be tested, while a metal nut and bolt, what you see in this example, for simplicity, it is going from abstract doodle to a concrete working model, right? So you can see here, the price will mount, the time and effort required to make a working model will also mount. Thanks to some of the new technologies coming, we are able to highly de-skill the whole effort. That is the topic today. I would like to talk, bringing ideas to life quicker and better. And time to market was always a problem, even today. But you can see in the pandemic times, the whole supply chain was stopped because of the global lockdown. So people had a great difficulty how to take care of those. you know but people who had agile manufacturing techniques had a better, they were better off. And due to pandemic, a lot of things needed hardware and all, people were able to do quickly using some of the new technologies which we discussed. So design is business of bringing ideas to life, right? Design and manufacturing, design and development is a business of bringing ideas to life. And we can say when you bring ideas to life, you need a very important thing, how to make it, art of making things. And we call art of making things as production technology. And in production technology, you have three types of main processes, the plus, minus, and zero processes. Of course, if we have a deep dive, we can see here three verticals: the additive processes, the forming processes, the minus or subtractive processes. So what are they? The additives are casting, welding, cladding, painting, plating, gluing, lamination, coating, 3D printing also comes, right? And we have zero or forming processes. There is no addition of material nor subtraction of material here. So you have bending, extrusion, drawing, forming, forging, coining, rolling, knurling, embossing. All these are zero processes or forming processes. Then we have the conventional manufacturing, which is largely comprised of turning, shaping, milling, drilling, planing, broaching, trepanning, sawing, reaming, grinding, filing, chipping, and it goes on. And you can see this is a very simple graphic which shows what is a cutting, what is a joining, what is a forming process. And man has been, toying with these, making things from the early civilizations, right? So here you can see a way of making pottery by pinching method, and this is like a turning method. And here you see there are rings which are put together one above the other, and you smudge them, and you get a pot, right? And this is resulted in a lot of these things. People used to use it for storing water, storing grains, and even storing their money. Recently somebody has got gold coins in Israeli, somewhere in the desert. So it used to, they used to be better than your PMC. Banks. You can store it below your own house in the earth. Early making was always handcrafted. It was born for self-use, most of them. Like how probably you have not seen this. The our grandmas used to make sweaters, for us, a topi for us, and all that. So it was for self-consumption. That gave rise to cottage industry, you know, and further it gave rise to a lot of things. What you see even today, this pottery, what you see here, has survived the antiquity. Even today, it is done with the same kind of water wheel, and we consume it, right? And handcrafting was always the case in the early medieval ages, and you have even today some of them survive, and you cannot have consistency here. You can have variety, but you cannot have uh, one kind in millions, you know because it's all handmade. So this led to what is known as industrial revolution, which made us look for things which are going to give us better efforts, the mechanical advantages. So machines were born, the hand tools were born. Hand tools, in fact, go to the antiquity. Man took a stone and made it into a tool, right? And we see today, you can see here, this is a early 18th century factory which has no machines, all ladies sitting and making sweaters, right? So the factory was born. And you can see the early revolution, industrial revolution, a landscape used to look like this: big chimneys, pollution, and slums developing, and city and industry was born. Industrial township was born. And then you have the production line system. This may look like a cow shed, but it's actually Ford Automotive Company's first production line. You can see how people are working, each one adding a bit to the product. And as the chassis enters in one end, the car goes out on the other with all the four wheels put, right? And then came the advent of electromechanical devices, valve, then transistor, ICs. So you can see there is a continuous digitization of manufacturing that started happening. So if we recapitulate all this, we have the so-called industrial revolution 1, 2, 3, and 4. Today, we are somewhere edging towards dreaming of Industry 4.0, thanks to the network which are available, which are not only 4G, 5G, 6G, and you have autonomous robots, you have uh, big data analytics that is possible because of the Moore's law, because the cost of computing and speed of computing has surpassed all the expectations, and today we can, uh, uh, dare to dream of Industry 4.0, and today many industrial giants are thinking of this Industry 4.0, and the 3D printing you can see here, which is a part of the uh, industrial revolution 3.0. So 3D printing is a new way of making things wherein people could convert any CAD into a part. It is a regime wherein people, don't have to have a blueprint and give it to somebody to machine it. So the skill aspect was taken care by a robot. I call it as robot because robots do their job. You don't have to instruct them anything apart from loading something, energy and programs, right? So same thing happens with the 3D printer. It is going to create objects directly from CAD data, okay, which is virtual data, and that is converted to a physical model you can hold in your hands. So this has made bringing ideas to life much easier, than before. And you can see it can not only make one-off parts, but it can make every time a different part. And so this is extreme agility that the technology offers. So in fact, people think 3D printing as different things. Some people say it is a liquid process. Some people say it's a powder-based process. Some people say, no, no, I have seen 3D printer works with a filament. I think they're all right. It is like blind people looking at elephant, thinking it is different things. So 3D printing is something like an elephant. There are different types such as SLA, SLS, FDM, LOM, binder jetting, material jetting, like that. We'll take a deeper look soon. Now we can see the conventional subtractive manufacturing. You can imagine, in order to get one component, you have to remove a lot of material. So that means a lot of energy required and lot of scrap that is generated. So conventional manufacturing was not in really a very efficient one. So if you compare it with the additive manufacturing, where material is used, to build instead of removing material, you can see energy required is less and scrap generated is also less. So we can say the additive way of making or 3D printing is a greener form of manufacturing. So thanks to Charles Hull, he's the guy who started it all. He called the process as stereo lithography. Stereo means depth, okay. Lithography means printing, so depth printing. So he said SL apparatus. He called it as apparatus. Even today, we still call it as SLA. A stands for apparatus here. So you can see how the early machine was looking like, with a CGA monitor, then with a variable transformer and a printer, which looks like a lab setup. Nothing has changed actually. The way he made it, even today, only size has changed, capabilities have changed. You know. So let us try to define this technology. So 3D printing refers to a set of technologies, not one, okay, which will help to fabricate a 3D object layer by layer from a digital input data. So this digital input data could be from a computer, hardware, where you can sit and create an entity, or it could be medical image data such as CT or MRI, from where you can also compute. If you integrate them, you get a volume and you can print them. Also, if I have a scanner, I can scan an object and take the point cloud data to make the part, and then once it is virtual, I can print it. So it's very important that you need a virtual computer data, that is the digital input data, without which you cannot print anything. So here there is a small animation. You can see the art, the sketch which comes out. It has to be converted to a virtual model. And once you do that, you need to triangulate the model, which can be understood by the machine, and then you can print it. So it can be different file formats, parasolid, IGS and all. It has to be converted to STL, and STL is then sliced, and slice is put layer by layer, you know. Uh, so it is just like, dematerialize and materialize. You put the slices back. So when it prints the slices, it is like a 2D printer. Only there is a Z, which is there, which is going to help you achieve the thickness, you know. So you can see here how the object is put back, the layers are recalled, and because the head is going up, you get an object. And Dr. Adrian and others have started, thinking this 3D printer can print itself, a parent and child. And soon the technology is one of it, that is FDM, became a open source, right? And today we are able to have a lot of such things, FDM clones, I can say, which are now used for making makers or the hobby people using it. I'm sure in IISc also you must be having a lot of such small printers, right? Now let us take this. This is a KUKA robot, right? It has got a dispensing unit attached to it, and you can see it is depositing clay. Is it a 3D printer? Well, yes, it is a 3D printer by definition, because it is depositing layer by layer. It is taking a digital data, and well, so that satisfies. So it is a truly out of the box printer, because you can print all over, you know. Especially I really like it. It is like your fast food, the um, Golgappa wala who gives you masal puri and pani puri and whatnot, all that. So you can stand in a queue, and you can, same thing can be done here. Uh, you can see here, this is a 3D doodler. So is this a 3D printer? It looks like a 3D printer. There is a filament going, and people are able to make it. Well, this is not a 3D printer. Why it is not a 3D printer? Because there is no digital input data here. If this is put on a robot, and you send the digital signal, then this will also become a 3D printer. Let us see how it works. You can see 3D doodlers are fun. Like a glue gun, you can make such things. And also there is no layer upon layer. But well, if we can discount the layer upon layer, if this is put on a robot doing the same thing, then we can still call it as a 3D printer, right? Well, moving forward, today there are a lot of different size and shapes of these. They handle non-metals and metals, you know, ferrous and non-ferrous, so their operating temperatures are different. Some are small, some are big, and this will be the future of industry. No grease, no sound, no great energy required. They all run on battery, connected to 5G, 6G. They can be operated anywhere in the world, right? So there is no need for such. So they are making this technology is making deep inroads in every possible sector. You can think of jewelry, medical, FMCG packaging, lifestyle, architecture, automotive, aerospace, and you have electrical electronics, white goods, plastics, and more. So this technology, what it offers, there are, according to me, as a practitioner for last 20 years, I in fact started running a 3D printer in IISc. In CPDM, in 2000, we acquired a little 3D printer called Prodigy, right? and I used to run it, day and night. Anytime I go, it was a one room, one mission, one key, and I used to do a lot of printing for EPIDAP and all. The mechanical engineering and the TCS. They had a collaboration, and we used to do a lot of things for industry also. And besides that, training, research, etc. So, according to me, there are six main features which add value for this technology. One is part consolidation. What is meant by part consolidation? So, if you think of a box, if you have a top lid and bottom, you want to open and close, so you have a hinge, right? And in order to make the hinge, you have part one, part two, and you have to put a pin and all. Then there are a lot of rivets which go. There are buckles in the front. Okay, today a box which was earlier made of 20, 30 parts, today we can make it out of just one part. So this way of bringing all functionality in one go is called as part consolidation. So bill of material of earlier 20, 30 will now become just one. So that this brings a lot of good reliability in the system. Now reliability depends on the number of parts, because the variables, each one can add, it becomes a weak link in the system, right? So part consolidation is one of the greatest uses or features 3D printing brings. And jigs and fixtures. Today, electronics is becoming miniaturized every day, and you cannot have a jigs and fixtures which is made on metal and kept. Earlier, like Ambassador car, the mold was used for more than 30, 35, 40 years. You know, Today it's all different. It has to change every day. Maybe every 6 months, people keep changing their molds also. So in electronics, it's much more. So jigs and fixtures in that sector, and also need for lightweighting. So where you need parts to be lightweighting, requirements are there in aerospace, because the payload is very, very important there. So the high strength to weight ratio you achieve by having a lattice structure, or a structure which is made up of Voronoi diagrams and things like that in 3D, or something like a form. They all contribute to make things lighter, right? And so also in jewelry people don't want to pay for what they want to wear. They want to pay less, but they want to show a lot of gold. So how you do it? You do it by scooping or making it lightweighting in some way, by thickness reduction, or by filling it lattice or something like that. The complexity. Now, complexity, this technology, what we call 3D printing or additive manufacturing, brings the greatest complexity that can be one can think of. Earlier, we had a lot of strict grammar. What can be done, what cannot be done. Today, thanks to this technology, we can do unimaginable things. Like what? Like for example, you take this. It's a ball inside a ball and ball. I've seen in Jaipur and all, इस पत्थर का हाथी होता है, उसका अंदर एक हाथी होता है, वो अंदर का हाथी का अंदर भी एक हाथी होता है. So that type of hand skill people have acquired to carve in stone. But if you want to make hundreds of them of the same size, shape, and all, it is difficult, right? And here you see this is an impossible object, because in CAD there is no gravity. So when I make it with a lot of voids, all floating in CAD, I export it and print it. And after I take out the powder from which it is made up of, sintered powder, that all falls off from these, you can see the voids, and they all fall one inside the other. So you get an impossible object, right? Which is very complex to make from injection molding or die casting or any other way we had before. And also, the world is going for highest complexity and lowest quantity needs. So need for one part. So how can you manufacture one part? आपका घर है, you actually manufacture it one part, right? You don't build many houses. When you come to cities, they manufacture houses one upon the other. We call it as flats, right? So still in the world there is a need for one part. So uh, this technology helps you to make one part. Now coming to the customization needs, any kind of customization, like we find in medical, a lot of customization needs are there. You require this technology, very badly, because all of us are unique people, right? We have our own unique dimensions. So if you want to make something suitable to humans, have a perfect match, you need this technology. Well, moving forward, you can see here one of the very typical example of the value what this brings. Uh, it, G is leap fuel nozzle tip, 20 parts to one part, and because of which it has become 5 times more durable, and weight reduction 25%, and it's more cost effective, 30% more cost effective, and also since it can be printed on demand, there is no need to keep the inventory. You know, you keep a digital inventory, recall whenever you require, and you produce on demand. So this reduces the inventory, carrying cost and things like that. Very important. So people using this technology have built very big things, like there's a small castle. Well, people have also demonstrated making small things. So this is IIT Kharagpur main building. You can see here below green scale there, 20 micrometer. So in comparison, some of the vertical lines, horizontal lines can be well over a micron thick or even less. Okay, so people are thinking of making biobots which goes inside the body, and they can deliver drugs using such small parts produced. In fact, in IIT Bombay, there is one professor, Prasanna Gandhi, who is working on micro stereolithography. Okay, so people all over the world are trying to think of producing things which are big size, producing things which are small size. Even the smallest printer can do a great job. You cannot underestimate. You can see the background. A memo is printed by the same small, humble 3D printer what you see in the foreground. And there are two things, important things we need to understand. In this technology, there is no economy of scale. That means even if I make hundreds or thousands, the cost will not come down. That is one thing. The maybe slightly it may reduce, a slight gradient you may give. On the other hand, the complexity comes for free. No matter whether you do a simple object or a very complex object, the 3D printer will not demand anything more. You know. So where do we apply this technology? You can see complexity is where this technology is best used. If you want to use it in the bulk production, like producing a washer, producing nuts and bolts, this is not a technology. It has to be applied, with its strength, not with its weaknesses. So injection molding and all are high volume die casting, high volume processes. Investment casting, vacuum casting, they come somewhere in between. CNC machining, again here, uh, they all have limitation in terms of how much they can handle complexity. When it comes to complexity, nothing to beat the new technology, 3D printing, right? And in fact, it also helps to make a small batch production. Once you make a 3D printed part, you can use it as a pattern, and you can actually produce. In fact, you can see a lot of things like this can be produced, in various shapes and size you can do. And design will lead consumption, manufacturing would be taken for granted in future. And I think we are it's 11:42 now. We'll try to go fast. All these technologies arrived. It is also very interesting that when we say customization and all, the children born in 2000 later, they're called millennials, and we have the Gen X, Gen I people who would want to be uh, uh, unique. They want to consume anything which is, they want to say, we have arrived, right? And they want to stand out in the crowd. And it takes all kinds to make a world. And we need to make customized things to everyone. And also, there is a human tendency, whatever you buy in the morning, we start hating it by the evening, right? And so the post-purchase dissonance is something which is also a very important factor one should understand. Now, today's clients, they don't know what to consume. So you can see, who are we clients? What do we want? We don't know. When do we want it? Now. So this is the kind of pressure the manufacturing sectors have. But with 15-day money back guarantee and all, manufacturing, what are they going to manufacture? Things which will be enjoyed and sent back to you. So uh, there is a new way to approach to bring ideas in future. They don't make anything. They will ask customer, you design and we make it. Or they have a gamification portal where consumers go in and they will start playing with it. And finally, they create a product for themselves. They feel that I have made it, right? And this is called as parametric design. And it is like a kaleidoscope, wherein you have all the system tools put in with the computing. At every twist of the kaleidoscope, you see a beautiful image. And whatever you like, you say, okay, I want this, let me have it. You go online and you pay for it, right? And that's how the design is going to be in future. And you can see some of these, you cannot imagine them because it has come out of mathematical equations, and you keep on giving n is equal to 1, 2, 3, you substitute like that, and find different forms coming on the screen. And at one particular point, you like it, you free and you export it and you print it. Something like that. These are all self-intersecting solids, surfaces, and it is not easy to imagine. So this is from a digital kaleidoscope. So let us demonstrate this. Let us take a simple band. On the right hand side, you have a lookup table with a lot of parameters. When you parameterize this, you can see the ring takes different forms, right? So this is going to be the future. People are going to curate designs. They put it. Designers will be in the background, and they create all the stuff. And user will just consume. He thinks he is the designer. You know, for example, even the sportwear, shirts, jewelry, spectacles, your food, everything will be done with the parametry in future. And even the razor maker has recently joined this movement. You can see, you can actually go to the website and choose whatever the handle you want. You know, so these are all available. So in future, designers will make it, contribute to such things where the user has an option to choose from, and they can also do a little bit of designing, right? So there is a co-creation that happens. So you can see here, people have a virtual reality, augmented reality, mixed reality coming into play, making an experience of consumption even before they buy it. They can try it out, right? And so this gives the so-called the new customer who doesn't know anything to actually find a lot of value. That's very important. You can see some of these examples. Somebody wanted gears for a phone, somebody wanted in gold, somebody wanted with a letter P. You shall have it, right? That is the beauty of this technology. And you can see here how some of these are articulating, and movement is there. Actually it is printed as one part. Can you imagine? There's no assembly here. Of course, putting diamond or filling enamel is a post treatment, and also the red necklace, which is having color red. It can be pigmented with any color, but basic stuff is 3D printed. Okay, and it is complex, right? There is no need for a laborer to assemble them, you know. So very important. In fact, world has moved into more value-added areas like R&D, design and merchandising, branding, licensing, marketing, and the manufacturing has actually the lowest value add in the you know um, whole thing. You know, whole world went into the world's factory, China, because this is what they saw: smile curve. You know, earlier it used to be a frown curve, which was the opposite of this. You know, where manufacturing was thought to be the most thing. Now today, manufacturing is taken for granted. Idea is important. R&D design is very important. You know, it's very so. You should take a note of this. And design will lead the consumption. Again, I want to reiterate this: manufacturing will be taken for granted. Okay. The future of 3D printing, moving beyond prototyping to parts for end use, and there is a steady improvement in technology. What used to be to make only mock-up model or dumb model, and to design validation model, and to a model which can be used, you know, at the end user application in the context, you know, where it is going to be used. And you can see some of the technologies are helping this. HP's jet fusion is a technology which is the solution cost is low, but speed is very high. And this is going to similar things like high speed sintering and all are going to disrupt and bring more such things into industry. And today we are able to have live hinges like this. We can even convert metal parts to polymer, and metal part is used only as an insert here. You know, such conversion is possible. You can see the complexity of these models. These are all models used for the end user application. Well, so you can produce just one, the minimum order quantity one. That is very important. You can see here is a sole which is designed for a particular player or a person, and there's a Bluetooth speaker, and there's a jewelry. We have seen it before, and these are cases for phone, and you can see this is a compliant mechanism. A compliant mechanism is that which is one part behaves as though it is moving, it is hinged, and it gives the maximum, life, because there are no moving parts. But moving parts will be there, but they are all produced together. So if a pneumatic, this thing is inlet here, they go. This is like a Borden tube, you know. They deform. Let me show you the animation now. See the capability. You can see when the compressed air or pneumatic system powers it, the whole system expands, and there is a tongue which comes, you know, and you see the application on the right side. Pick and place, a robotic, a pick and place actuator is actually made out of this, and it's a compliant mechanism. So you print this as one part and use it. It will have maximum life, believe me. Compliant mechanisms are studied, you know, with great interest. Earlier also, it is almost 100 years old, but they were not able to actually make it. Thanks to new technology, it is able to make compliant mechanism work, and so it is actually being adopted widely now. You can see the dexterity of hand can be now brought in robots, because some of these new forms can be made easily, tried out, you know, and so we are going to have more and more human-like computer robots with which are just like going to ape your nimble hands to carve out things in future. And optimization of parts are going to happen because of the mathematics, the topology optimization, artificial intelligence, all these things come, and the digital manufacturing is going to be driven by such tools in future. So designer has to think and choose. So, he will have a different role to play. So some of these can be virtually tried out and done. You can see here the properties can have different properties can be incorporated by having lattice. Just like how you have in nature, you take bones or you take the tree branches and many such things, even the shells. They're all made up of such varying properties. You know, and such things are possible today thanks to the new technology. Even the building facades are going to have the climate control and all are going to be parameterized in future. So you can see some of these, the window where you can at will you can open and close to allow the light or the heat control within the building. Such things are possible. And looking forward for future, you have microfabrication possible, mega sized things can be possible, small and medium and large size are possible. And in fact, small and medium will now move to include large, while microfabrication will remain as a specialized one. Mega will also remain, and small, medium, and large, they will cater to the world needs. You can see individual designer, maker, and artist will depend on a cloud factory. So today we have a cloud factory at Imaginarium. You upload anything and you demand what material, what finish you want, and you will get it. So the future factories, the OEM, MSMEs, and SMEs may use printers, but individual designer, maker, artist will depend on the cloud factory. In fact, 3D printing itself, the so-called hardware, will become like a screwdriver. Who cares actually something is 3D printed or not, as long as you have it. In fact, you can have these parts in any material you want. So it can be a transparent one. It can be a transparent one. It can be a translucent one, as you see here, or it can be a metallic one. It can be a metallic one. You can see these are metal, right? So all such things can be made by this technology, at a click of button. And in the scheme of Industry 4.0, additive manufacturing is a important player in the cyber physical system. It brings the physical side of it, right, along with the so-called the robot and CNC. So they form what is known as the hardware trinity. Hybrid manufacturing systems are already making their appearance in the manufacturing sector, and Industry 4.0 will have lots of such systems. You know, so there is a digital switch in SCM, supply chain management. Supply chain will become demand chain. And product will transform into value. So the focus will be shifted from product to value. You know, the whole world, if you see the ecosystem, idea and design enters here. They have to become a CAD model before you can actually 3D print anything. So reverse engineering or from the top, design for additive manufacturing, because we need to unlearn the ways of earlier methods in order to use this technology. Then of course you have pre-process it, and 3D printing needs material and also care. Post-processing is required, and then you have the world of opportunities. This forms the spectrum of the digital manufacturing. And in fact, for COVID time, we have done a lot of such products. As you can see here, ventilator splitters we have done. You can see how they are applied, and we have done the venturi valves also on demand. Many things we have done like this. Even the door handle, and we have done such quickly. With laser cutting and 3D printing, we are able to do many things much faster. The whole world is looking at different ways of making things, and in future 3D printers will be actually robots. You can see how it is making, from digital input data, creating things horizontally, vertically, and otherwise. On the right hand side, you have a rocket, uh, being made by a Starex 3D printer, which is essentially from a robot depositing metal, right? And this is from relativity, the so-called competitors to your SpaceX. They're also working on space programs. These are the future, of this technology. I think with this, let us have this um, a wonderful statement. Let us recall: I do not fix my problems; I fix my thinking. Then the problem will fix for themselves. Very nicely said by Lucy. And Imaginarium is a company which has got different verticals, starting from Imaginarium Rapid, Imaginarium Special, Precious, Imaginarium Live, Imaginarium Solution, Imaginarium Academy, and Imaginarium Venture. We are trying to spur the industry, and you have my email ID, you have my phone number. We have our, if you want to have a virtual tour, do visit our website at www.imaginarium.io. There, if you have a VR gear, you can wear the gear and see the virtual tour of the shop floor as well as the corporate floor. Or you can also see it on a normal phone. You have an option. Um I think with this, we come to the end of today's presentation. And if you have any questions, let me take it. Thank you.
Thank you so much, sir. So we have quite a few questions over in the live Q&A section. Let's take them one at a time. So firstly, one of the people have asked, this is actually something that I quite resonate with. The question is as follows: how big of a challenge does being eco-friendly pose to the 3D printing industry? As in, uh, does 3D printing is 3D printing more environmentally friendly? If not, what can be done to make it more so?
Well, very nice question, and it's quite often asked. So I'm well prepared for this answer. When we started, it started with polymers, and polymers themselves are not very good material. Plastic, any kind of plastic. So people are looking for bio degradable plastics also. Reduce, reuse, and recycle is a very good approach for plastic, because if you can use a plastic tank for 100 years, then also it is eco-friendly. We should not throw it. Whatever we throw it, whether we fill it in earth or in the ocean, it is going to create problem, right? And so reduce, reuse, and recycle is the way for polymers. uh, and of course it is for even metal. Metal cannot be used for many number of times, except few, like aluminum you can use any number of times. So we need to go with those material. So as a designer, we need to be very conscious of this. We have to be responsible when we are creating things to do or not. That is very important. And 3D printing is no different. In the early days of 3D printing arrival, the polymers were used, so they were totally not good at all. And today, more players are there, more material research is going into the system, and more funding is there. So people are looking at biocompatibility. So one of the material is polylactic acid, PLA, and PLA is also it is debatable how eco-friendly they are, but it is made up of cornstarch, right? So
Mhm.
people are using, but some of these have they lack in strength. you know so how to have good strength at the same time bio friendly materials, because a building, if you construct out of a bio friendly material, it can be infested with something, and microbes or fungus or whatever. It may, whole structure may come down. But if I make a structure which will stand for 1,000 years, then I don't have to worry about it, right? So there are different approaches in this area. There are a lot of biomaterials coming, biocompatible materials coming, bioabsorbables coming, you know, and people are able to print drug, people are able to print food, people are able to use edible material, you know. So there is a whole lot of approaches which is going into the system. Okay, so I think it is research. By good research, we have to take care of the earth, you know, so that the responsibility is in our hands, your hands also. Hope I have answered the question.
Definitely, sir. So then there's another thing. There's someone interested in design, and they're asking what are the things that a designer should keep in mind while designing something that is going to be 3D printed? For instance, one of those impossible objects that we printed. What kind of process goes into the actual design?
Well, today I did not take you to a deep dive into technology because I wanted to make it very light. In fact, if you take the deep dive, this impossible object, what you see, is actually printed out of uh, powder. You know, it is a powder sintering that happens. You're able to see it.
Yes, sir. Yes.
And so it's a powder. So powder is actually sintered layer by layer, and it is full of powder surrounded by even the object after sintering is surrounded by powder. So when we sandblast it and blow away the powder, what you get is a part that comes here like this. And so the powder based systems are very good, and of course in polymer it is very good to do. In metal it is more difficult because in metal supports are there, and they will create a lot of problems. Okay, there are advantages and disadvantages with metal. Metal is more durable, and we can use it for a longer time. And even today plastics are coming with carbon fiber. You have exotic materials like Altem, ultimate materials are available, peak is available, and engineering plastic like nylon 6, nylon 12 are available, and people are able to make titanium and different alloys. The exotic alloys like molybdenum, vanadium, all such things are also going to be used, because the beauty is we are able to have a control on a layer by layer. You can also have a control on a pixel or a 3D pixel called voxel. You're able to have a control over it. So if you have a casting, no, you pour a casting, you cannot control in a particular area anything. For which you need to do some kind of a treatment like carburizing, tempering, annealing, and all. But in case of this, so the processes are different processes are deployed to achieve what you want. Um, I think I forgot the question. Can you repeat? I thought
Yeah, so the
I'm.
question, so the question was as follows. A person interested in design wanted to, find out what are the things that a designer should keep in mind when he's making the digital design version of something that is going to be 3D printed.
In fact, all the rules you can throw them away. You can design anything. 3D printing can be done. So you don't have to worry about any kind of principles as such. But of course, if I want to print in a particular material that is not available, probably you may have to wait for some time. That material has to be researched and made compatible to work for you. Okay. Otherwise, today people are thinking of printing, organic things, including people are thinking of printing body parts, for example. People are thinking of printing the meat, for example. They want to make an organ to check the drug efficacy. So today I did not go deeply into the medical side of it, which is also quite rich. In medical area, people can do a lot of things. So as a designer, I don't see you do have any constraint. You can freak out. You can freak out and design anything, and that is possible, and that is possible to make. You know, the earlier days used to have design for assembly, design for manufacturing, design for that, design for this. There was all bringing a lot of constraints into the system. Today, you can dare to freak out with design and get it done. So it's a wonderful time to be alive.
Definitely, sir. There's another question that is rather personal to your company. As in, the question is as follows: what is the largest component that Imaginarium has manufactured? And what is the cost comparison according to you in India when it comes to 3D printed products versus traditionally manufactured products, especially at the large scale?
Well, I think largest part we have done, as I told you, 3D printers machines, they come in a finite size. They don't come in infinite size. So uh, we can make at a time something like 600 by 700 by 500, cube, is the largest capacity. But we have done parts which are 22 feet long also. That's by actually joining them. Okay, 22 feet things we have done, and also we can do it in metal and non-metal, transparent, opaque, and different types of soft and hard. A combination of soft and hard. We can make all those things a possibility. And the second part of the question was, what was the second part? The first part is size, cost. The cost is something comparable because Imaginarium is into making jewelry since 2003. Okay, we are into rapid manufacturing of jewelry. Okay, what you see here is a metal. Okay, it fell down. I will take another one. So here you can see this is a matte finished metal part. You know, is a metal part, and it is done indirectly. So you can see it is plated. This looks brass. It is the inside is brass actually. It looks yellow and rhodium plated and sandblasted. That's what you have, and you can have even a glossy one like this one. You know, so all these compete. In fact, world's some of the most complicated jewelry is done by Imaginarium. And what is the order quantity? Just one. So if you have a doodle, you want to gift it to your loved ones, your parents, your grandpa, your girlfriend, your boyfriend, your teacher, to thank them, on a particular day, you can create your own and share the doodle with us. We convert that into a CAD and then we make it and give you. So many people for a wedding and all, they are coming to us for special occasions. They come to us and we make it. It's not only in jewelry but also in the other sides of manufacturing. People have done. Somebody wanted to celebrate their win on a particular device, so they made a small miniature of it. Many of them they gave it to their clients. And it is not just that making things like some of the companies, I cannot show those because we are bound by the non-disclosure agreements, confidentiality. So some of the projects what we do for aerospace, for automotive, many times you cannot make out whether real or they're 3D printed. They look so real and they function like real, and they're just made one. So likewise, we have done fridges, we have done washing machines, we have done fans, we have done dashboards, and they're all big, right? So what we make typically, we digitally cut them, join them, and then finish them and paint it. So so it's raining heavily now. So we are going to have such things possible. So today you can do almost anything. You know so ideas can be brought into reality. In between, the making is now de-skilled thanks to this technology. So you don't have to be a skilled artist to bring your idea into a reality. You think about it, you make a CAD. If you cannot make a CAD, you come to us, we make the CAD. you know or not only to us, anyone who has such capability, you can go to them, and this is a new way of making things. Yes.
So maybe let's just take one last question.
Yeah.
The question is, what measures do you think the Indian government can take to ensure that the 3D printing industry flourishes further?
Well, this is our continuous effort, in order to bring this new technology to uh, greater reach. It has to become more viable, right? Feasibility is there, you know, desirability is there, but it is not viable many times because it is costly. Because many of these technologies still are patented, and when you want to bring, there's a technology cost to it when you bring it to India. So these are, and also these equipments, some of them are having heavy duty, when they come inside, and you have to import some of these raw material also. Then they're all having their import duties, So by actually making somebody, borrow the technology transfer, they buy the technology and make it in India, could be a great thing, So government can help in that respect. And also, this has got a GST of 18%. In order for this sector to flourish, they can give some kind of a moratorium on GST, for say 5 years, for some time. So people, like you and me as consumers, we will, what is it is going to reflect as, it will be your landed cost will be less. Correct? No, you can buy it better than what. So people, when they want to buy and make a design, if it is very costly, they make only one, and they test only one. So if it is cheaper, you tend to make more of them, no iterations, and you can test them because it is, after all, cheaper. So when it gets cheaper, I think India Inc. as an industry will greatly be benefited by actually trying to make more things, which can be, uh, helping industry to actually innovate better, and it will also help India's journey in its, make in India journey could be much better. You know what you have seen, what happened to COVID time, and how people have responded to that. Making agile manufacturing, you making use of the technology. So if the same thing can be also put to India Inc., with the government efforts, it will definitely help. And India has a greatest advantage now with the geopolitical shift. You know, India can has an opportunity to capture, but are we ready? Is the question. So government can actually look at it and help, the sector to be more viable to users, and making some of the shops, offering shops, they can help. And I have been trying to influence it by participating in FECI and CII, and requesting authorities, to give a, a, a priority, or making it subsidized, can help actually. I think this satisfies your question. Your,
That is definitely the best answer we could be looking at. Thank you so much, sir. I think with this, I'll bring the question answer session to an end.